Same directions, different function. Now, you're going to get to a point in this one where you think, man, this looks awfully familiar. This one has one little catch to it that's really neat. So I'm going to graph this one in a calculator. So 6x minus 12. If you're graphing in a graphing calculator, you do need parentheses around the entire numerator because it is more than one term, and the entire denominator because it is more than one term. So 6x minus 12, and then x squared minus 2x. Whoa, all that parenthesis talk, and I didn't do it. Been doing this for decades and didn't do it. Man, it's awful. All right, there we go. What I want to do is figure out what happens if I plug in each of these, and when I do, let's go to the table, fill those values in. By the way, if you're following along on a calculator, what just happened was I pressed second and table, but I have it set, watch this, second table set, to where the independent variable, it'll ask for it, and you can type whatever x value you want, it'll give you an output. So that's what we're about to do. So negative 12 is negative 0.5. Oh, that looks familiar. Let's start filling that in. This is basically exactly what you had on the other side of the paper, up to a point. And you're going to be like, oh, wow, this again? Negative 10. Oh, negative 0.6. Negative 8. Negative 0.75. And if you're like, man, I'm just going to copy the other side of the paper, yeah, have fun with that, because in a minute we're going to get a little hiccup, and you're going to see why. Negative 6. Negative 1. Negative 4. Negative 1.5. Negative 3. Negative 2. Negative 2. Negative 3. Negative 1. Negative 6. Negative 0.5. Negative 12. Negative 0.25. Negative 24. Negative 0.1. Negative 60. 0. Whoa, error. Can't do it. Can't do it. Okay, so we're at the halfway mark. We still have the same situation where we're not able to divide by 0. That didn't change since we did the other problems. Still unable to divide by 0. So this one's going to be undefined. And we're going to keep going. 0.1 is 60. Now you're like, man, just copy these. Hang tight. 0.25 is 24. 0.5 is 12. 1, 6, 2. What? This is why we didn't copy them. Okay? Because you're tempted to put what you had here, just opposite sign, right? So like the negative 2 and the positive 2 would just give you negative 3 here, positive 3 here. I mean, it worked here, right? Are these the same function? Nah. Are they? They look alike, but not really? Yeah, we'll see. Okay, so this one was undefined as well. That's odd. That's really bizarre. Okay, keep going. 3 is 2. 4 is 1.5. I wonder if there are any more surprises. 1, 8, 10, and 12. Ah, no more surprises. I knew that. I was just stringing you along. Okay, so we're going to plot some points. We're going to plot them, well, quickly, because we've done this before. Now, if you wanted to, you could just sort of look at your graph that you did a minute ago, and you can copy it up to a point, but there's one point, literal point, you can't use, and that point you can't use is 2, undefined. So 2, what? Okay, don't put that point, that one right there. Everything else is going to be the same. So I'm going to go through this very quickly. I'm not going to put all the points. I'm going to put a lot of the integer points. I will put some of the, like the 0.5s and stuff. So negative 12 is negative 0.5. Let's skip a couple. Negative 6 is there. Negative 4, I will put that one. Negative 3. Negative 2. Negative 1. Negative 0.5 is negative 12. That's sufficient. We'll do that. Okay. There we go. Graph. Looks exactly the same as what we did. Yeah. That's it. Now let's graph the other ones. So let's see. 1/2 was 12. So dot there. 1, 6, dot there. 2. Okay, I really want to put a dot at 3. And I told you not to, and I'm not going to. But I'm going to do that because I know what's coming. Open circle there. For real. Trust me. 3, 2. Do you trust me mathematically? 4, and then 1.5. 6, 1. And then a couple that I want to skip, and then 12, and then 0.5. There we go. So we're going to connect those as much as I feasibly can. There we go. There we go. We'll keep drawing this one. Come out with that. There we go. We'll do that right there. All right, so now we're going to talk about discontinuities. So we have a discontinuity, well, a couple discontinuities actually. So the question really is, where or at what x values do I not have a graph that exists? So there is a non-removable discontinuity at x equals 0. There we go. We'll turn that into an x. Now we also have another discontinuity. It's a place where if you were driving your car, first of all, you'd go way on down here, whatever that is. So clearly non-removable. These pieces won't ever meet no matter how hard you try. And there's your other one. But these two pieces would meet very easily if you just patched up this hole. This is a removable discontinuity. So there is a removable discontinuity. Now, if you're tired of writing the word discontinuity, just call it disco. That's totally fine. At x equals, where was that? It was at 2. All right, so we're going to talk for just a minute about why this is. Well, first of all, you're not allowed to divide by 0, which is the reason that this whole situation happened in the first place, and it did happen on the other side as well. 6 over 0, yeah, good luck with that. But why did that happen with a 2? So why does it happen with a 2 here? So what I want to do is write the original problem again. We had f of x equals 6x minus 12 over x squared minus 2x. And we're going to use some of our skills that we have gained from factoring, because we know how to factor. And when we do that, we're going to factor out a GCF. We're going to have x minus 2 right here. And we're going to factor out an x there, and we're going to have x minus 2. Oh, do you see it? Do you see it? I really hope you do. I desperately hope you do see it. And the thing that you're supposed to see is the obvious thing that you've done time and time again, where these two things cancel out. And you're left with 6 over x. That's why this graph that you just did was exactly the same as this graph, except at one point. And that one point was at 2. That's the only exception. So that one point was at 2 because of these things that I canceled out, and I don't want to just toss them out. I would say that this is true, but this is only true where x is not equal to, okay, so what would I plug in here to end up with a 0? Well, 2 minus 2, and then I have 2 minus 2 over 2 minus 2. So if x equaled 2, this, other than at x equals 2, let me word it this way. Other than at x equals 2, this is equivalent to this. For this one, I can plug in a 2. Right here, I can plug in a 2. For this one, I can't. So I want to say, okay, well, this is true, but x, where x is actually not equal to 2. Sorry about that, little brain fart. So this is now equivalent to this because we said, you know what, I can't plug in a 2, and let's just say I can't plug in a 2. Now, if I do plug in a 2, what do I have? I have 2 minus 2, 0 over 2 minus 2, 0. 0 divided by 0. Whoa, okay, that takes us way off track, but let's explore it. What's 0 divided by 0? Well, 0 divided by something would be what? 0. Okay, sounds good to me. Well, let's see. Anything divided by itself, we've heard, is 1. And then something divided by 0 is undefined. So now we're in this situation where, okay, we have a 0 in the numerator and we should get 0. We have a 0 in the denominator and we should get undefined. And we have something divided by itself and we should get 1. So what is it? Good luck with that. It's indeterminate. So when I say it's undefined, that's true, but technically the phrase for that one would be indeterminate. You have, right here, a hole in your graph. Holes are removable discontinuities.